Oh, I cannot get a GPS signal. Oh, no satellites. Man, I cannot get a GPS signal in here. I've got to get a hold of my friends for the show. We've got to film that show soon, and I can't get that GPS signal. There's never a satellite around when you need one.
What are you talking about? There's plenty of satellites. Just look around.
Dr. Andrew Johnston, you're a geographer here at the Smithsonian. Maybe you can help me. You know a lot about satellites, right?
Yeah, I sure do.
What kind of things do you do with satellites?
Well, we use satellites to understand the Earth and how it changes through time, because some satellites take pictures. But we also use GPS satellites to understand where we are. Here's the globe I always carry around with me wherever I go. So some satellites orbit very close to the Earth. We call it low Earth orbit. It's about this high up. Other satellites, like GPS satellites, orbit at about this distance. Then still other satellites are out in what we call geostationary orbit. That's very distant, like some of the weather satellites that we have behind us here. Right.
What else is up there? Are there aliens, little green men, UFOs?
Well, there's all kinds of crazy stuff in space. Can tell you, we don't have little green men or UFOs, at least anywhere close to the Earth.
Is there anything up there other than the satellites?
There are pieces of debris. We sometimes call it space junk. Some pieces of space junk are really large, like discarded rocket engine. Sometimes they're really tiny, like little flecks of paint. So there are thousands of these things that still orbit the Earth. But the thing about space, you got to remember, is that there's a lot of space up there. Even close to the Earth, where the density of these objects is pretty high, there's a couple hundred miles between each of these objects. But the problem is they move so fast that when they do hit each other, it can cause a lot of damage.
Hopefully none of that space debris will hit the GPS satellites I need for this. Should we go outside and see if I can get a signal now?
Yeah, let's go do it.
Great. Oh, great, I've got signal now, but none of my friends are where they're supposed to be to get here to film the show. I need to signal them. Great, now they can get here to film the show.
What is the show called?
This is STEM in 30. All right. Hi, I'm Marty Kelsey, and I'm standing in front of the selfie wall here at the Smithsonian National Air and Space Museum. I'm in the Outside the Spacecraft gallery, which showcases spacewalks throughout history. You can see here we've got a really cool display of spacesuit gloves that have been used. Some of them are test models, and some of them are actually the molds that from astronauts' hands. You can go online to the Smithsonian website and actually interact with this and rotate the gloves and really see them up close. I would like to thank you guys, first of all, for being here. These are my friends from Friendship Charter School. Thank you guys for being here today. I'd also like to welcome our online viewers on the Smithsonian website and also with the NASA TV audience. Thank you guys for joining us. I'd like to remind you guys that you can participate online. If you go to our website, you can submit questions, and we have a docent standing by to answer those questions. Some of them we'll actually use on the show today. Does that sound pretty cool?
Yeah.
All right. So to start with today, I'm going to give you guys a 30-second challenge. I'm going to put a picture up on the screen, and I want you guys to think about it, talk to your partners, and make a guess about what you think this is. Let's see if you can figure it out. Here is your 30-second challenge. Go ahead. What do you think it is? What do you think?
I think it's the bottom piece of a glove.
You think it's the bottom piece of a glove. Great guess. Who else has a guess? Go ahead.
Rusty ring.
A rusty ring. Another good guess? Well, I'm joined by Dr. Kathleen Lewis. She is the curator for international space programs and spacesuits here at the Smithsonian, and she's going to tell us a little bit about what this is.
Ну, это самый последний кусочек.
Wait. Are you talking in Russian?
Yes, I thought you wanted it in Russian.
No.
It's a Russian object.
Let's do this in English today.
Okay, very good. It is the last remaining piece of Sputnik, the first artificial satellite of the Earth. It is an arming key, and it came from the satellite before it was launched. Sputnik itself was known as this beep heard around the world. It was a very simple satellite, affectionately known in Russia as the simple satellite. It just had a broadcaster, two transponders, and a battery to keep it going, and it emitted a beep that radio amateurs could hear around the world. But of course, being able to send a signal like that, it needed a battery. And it had more than half of its weight of this whole entire satellite was its battery. So to keep the battery from discharging during the manufacturing process and when it was transported from Moscow, where it was made, to the Baikonur Cosmodrome, which is in Kazakhstan, in the Kazakh Republic of the Soviet Union, former Soviet Union, they had to have an arming key. And this arming key separated the battery from the transmitters. And when the engineer who was in charge of making the spacecraft and mounting it on this launch vehicle, his name was Oleg Ivanovsky, carried it from Moscow to Baikonur, and he mounted it on the spacecraft. He pulled out the arming key, put it in his pocket, sat the satellite on board, and it continued to broadcast when it was in orbit for about 2 months. And then its orbit decayed in about January, about 3 months exactly to the date of its from the date of its launch. And the arming key is really all that remains of that original satellite. As it was mounted.
That's absolutely amazing. Thank you so much. Now, my co-host Beth Wilson had a chance to go out to the Udvar Hazy Center, and she was looking at some satellites. Let's go out and see what she's up to.
Hello.
Hi.
Hi, may I help you?
I don't know, do you work here?
I do. My name's Roger Thompson. I'm a docent here at the museum, and I'm also a rocket scientist who works for the Aerospace Corporation.
That's great, because I do have some questions. There's all this stuff in here. Is all this stuff in space as well?
This is just a small fraction of what's actually in space. The U.S. Air Force tracks large objects, and when I mean large objects, I mean anything 10 centimeters or larger, so about the size of a softball and larger. They track over 22,000 objects. Only a little over 1,000 of those are active satellites. The rest is what we call space debris or space junk.
And what is space junk?
It is any man-made object that is in orbit around the Earth that is not an active satellite. Some satellites are space junk, the ones that are inactive, they failed, or they've reached their end of life. Rocket bodies that deliver, or rockets that deliver satellites into orbit are also typically space junk because they've done their job when the satellite is there. And then we have fragments and pieces of spacecraft and rockets where the rocket may have exploded, the satellite may have broken up, and a few that have collided.
Why aren't they coming down? Why are they still in orbit?
The big problem with space debris is in the area we call low Earth orbit, or LEO. That is the region of space near the Earth where most of our satellites fly. It does also have a little bit of atmosphere, but it's very, very thin. And so the drag that is created as a satellite goes around is very small, but it adds up over years and years and years. Some satellites will take over 200 years to re-enter. Some will re-enter in a year and a half. And some of the fragments, the space debris, will be anywhere in between.
So what would happen if something maybe this big hit a satellite like this?
The damage that's done is related to something we call kinetic energy. Kinetic energy depends upon the mass of the object, how much it weighs, and the speed that it's traveling. Well, at 17,000 miles per hour, speed's the predominant term. So the kinetic energy of these collisions is extremely high, much higher than anything we have experience with here on Earth.
Thanks so much for covering this with me. I appreciate it.
Thanks, Beth. Now, as Dr. Thompson was telling us about, space debris is all about kinetic energy. And kinetic energy is the energy an object has because of its motion, how fast it's going in space. So orbital debris has a lot of velocity, a lot. And so the more velocity something has in space, the more damage it can do. Let's check out what happens if a little piece of debris hits a satellite.
Here we have our friendly everyday satellite. But in space, there are all kinds of dangers, like deadly orbital debris. A piece as small as the head of a pin has a pretty good punch, because it is moving over 17,000 miles an hour. A little bigger piece, something the size of a bolt, packs an even larger wallop and creates even more space junk. There are not a lot of wrenches floating around in space, but a piece of debris this size would cause catastrophic damage, turning our once useful satellite into even more space junk.
So the museum is full of all this stuff. Is any of this considered space junk?
Almost anything you see around here that would be a payload, a satellite, or an upper stage, the part of the rocket that delivers the satellite into orbit, would be at one time or another space junk. The Agena upper stage, for example, is one that we launched a lot of them in the 60s and 70s, and almost every one of them was at one time space junk. Some of them have re-entered, but there's still quite a few that are on orbit.
So we have all of this debris out there, and yet we're still launching rockets. How do we do that?
We use the mathematics to determine when the rocket on its path is going to come close to some of the space debris. We know which orbit the satellite's going into, so we have the trajectory of the rocket. We have orbit data that tells us where all of the space debris is, and we can estimate where it's going to be at a given time. And so we can use mathematics to figure out when the rocket and the space debris are going to come close to each other. If it is too risky, we can flag that as a bad time to launch the rocket.
Is this debris ever going to prevent us from, say, returning to the moon or going to Mars?
We don't think so, but that's the big question. It's called the tipping point. When has the debris become so dense and so much of it in orbit that you launch a satellite and within a year or so it gets hit by something and creates more space debris, and that hits the next satellite and the next one and the next one? We don't think we're there yet. The research doesn't seem to indicate that if we don't make things a lot worse.
Can't we just clean it all up?
That's a really hard thing to do because it's traveling at over 17,000 miles per hour. You can't simply put something in its way and let it collide with it. That just creates more space debris. So you really have to rendezvous with it, grapple it, hold on to it somehow, and pull it into a lower orbit so that it will re-enter naturally in a much faster rate than it normally would. That's difficult to do with 22,000 objects.
So if we cleaned it all up, you'd be out of a job?
I don't think so. We're going to continue to launch satellites, and there's always the potential of something running into something else up there. So there'll always be something in space.
Well, I'm glad you're watching out for us.
I'm now joined by Dr. Andrew Johnston, and he's going to answer some of your all's questions about satellites and space junk. But first, we've got a video question from South Valley Middle School in Liberty, Missouri.
Hi, my name is Claire, and my question is, could another planet form from all of the space junk?
Well, that's a great question. The answer is no, not really. If you add up all of the stuff that we've launched into space, it would altogether weigh a few thousand tons. That sounds like a lot of stuff, but it's still a tiny, tiny fraction of even the size of a small asteroid. So there really isn't enough stuff out there to form something that we would call a moon or a planet.
Cool. Great question, Claire. All right, we've got an audience question.
How far is space junk from Earth?
Again, another great question. Well, you saw some graphics before that showed how far away some satellites are. Some satellites orbit many thousands of miles from the surface of the Earth. But out there, it's a popular place to put satellites, but we don't have the problems that we think about for space junk closer to the Earth. That low Earth orbit area is where there's a higher density of objects, and that's a few hundred miles up, maybe 200, 300, up to 500 miles above the surface of the Earth. That's that zone where there's a lot more material, and people do worry about things colliding in space. It's happened twice in the last 10 years where we've had a couple of objects hitting that produce even more tiny shards of debris.
Great. All right, we're going to go to an online question now. What satellite has been in space the longest?
The longest orbiting satellite is called Vanguard. That was actually launched by the United States. You mentioned Sputnik before that orbited. That didn't even orbit a couple months. But one of the spacecraft launched by the United States after the Soviet Union, there was Explorer, and then there was this Vanguard. And that satellite has been orbiting decades ever since it was launched.
Wow. Awesome. Well, thank you so much for answering our questions. Now, I had a chance to go out to your all's school last week, and we did a lesson where we simulated spacesuits. And so we're going to head back out to your school and see how that lesson went. Guys, I am excited about this today. We are going to be building and testing spacesuits. But not just any spacesuits. We have very special astronaut stand-ins today. We have tater-nauts. Okay? And so what we're going to do today is we're going to build a spacesuit for our potatoes. Now, a real spacesuit is made up of all kinds of layers. This is a cross-section of a real spacesuit. And you can see it's got all of these layers in it. And each layer serves an important function. It does something different. And so when they build spacesuits, they have to think about a lot of different things. They have to think about the temperature ranges that they're going to be used in. Really high, really low temperatures. They have to think about radiation. They also have to think about impacts from space debris. Space junk flying around out in space could hit a spacesuit, and so it's got to protect the astronaut from those impacts. It also has to be comfortable. So we've got all of these things that we've got to make sure our spacesuit does for our astronauts when they're out in space. You guys today are going to be testing for that impact resistance. Now, to build our spacesuits, we've got some different materials. We talked about the different layers that are involved. You guys are going to create a spacesuit that's got 4 layers max, 3 if you use any gold foil. You guys ready to build some spacesuits?
Yes!
All right, let's build some spacesuits. You guys looked like you had a really good time building those spacesuits, didn't you?
Yeah.
All right, so the way that we did the experiment was we tested those suits. And for our experiment, we had a punch, which has got a lot of mass compared to orbital debris, but we didn't drop it very far, so it didn't have a whole lot of velocity. In space, that's the exact opposite. We have a very, very small mass, but a tremendous amount of velocity. So here on Earth, to test these spacesuits, this is a pretty good demonstration. Should we see what happens to a potato without a spacesuit?
Yeah.
All right, so let's count down. Let's put that on there. 3, 2, 1. Oh, that does not look like it's going to be a good day to be a potato, does it?
No.
Should we go out and see how your spacesuits did when we tested them?
Yeah.
All right, let's go check that out. Guys, you did a great job building your potato nuts. These are awesome. You guys ready to test them?
Yes.
All right, now, I've brought in a special guest today to help us test them. I'd like to introduce Dr. Donald Thomas. He is a NASA astronaut. He's
How you guys doing?
Good. 4 space shuttle flights, over 1,000 hours in space. He's flown 17 million miles in space. Thank you so much for being here.
Hey, it's great to be here today. I love your potato knots here. You guys ready to test these?
Yes.
As you heard, I got to go up on 4 space shuttle missions. I went around the Earth 692 times. And a spacesuit is so important. That's what helps keep the astronauts alive and healthy and comfortable up there.
Now, you had some experience on a couple of your flights with orbital debris, right?
Yeah, every now and then a piece of orbital debris, hits the space shuttle. There's a lot of old satellites up there, rocket stages, small particles, meteorites passing through space. And on one of my missions, on two of my flights actually, we got hit by something. And on my last flight, I happened to be looking out the window having lunch, and I'm watching the Earth go by. And I see a little drop on the window, and I thought it was some of my orange juice that I was drinking. So I took a napkin and I went to wipe up the juice, but it didn't disappear. It wasn't a drop of juice. So I went up and looked closely, and it turned out to be a little crater in the window. So something had hit us. Even a small particle like a grain of sand, when it travels at these high speeds that we travel up in space, like 18,000 miles an hour, it can do a lot of damage. It has a lot of kinetic energy, we call. And some little particle hit us, formed a little crater in the window. Later on the next orbit, when we saw like a sunrise, I could see the impact, like the little vaporization. Whatever hit us vaporized, and it had a little ray pattern like a crater on the moon, about 6 or 7 inches across. It was really amazing to see this. So it reminded me there's a lot of space junk out there. And that's why it's so important with our spacesuits to protect our astronauts. When they're outside doing a spacewalk, working on the space station, these spacesuits are what keep the astronauts healthy, comfortable, and alive, and protect them from the hazards out there.
All right, are you guys ready to test your potato?
Yes.
All right, let's see how it does.
Shall we do a countdown?
Yes.
3, 2, 1.
Ooh, I don't know. Let's see. Check out, that's a pretty good sized dent there, isn't it? That would hurt, but let's see if it actually held. You guys see that? Doesn't look like too much damage. I think you guys' potato survived.
Did all right. Good job, you guys.
Good job.
Great job.
What's your tater-naut's name?
Adopted as Hamburg.
All right, let's see how it does.
3, 2, 1.
Ooh, let's see. Right in the face. Now, spacesuits, they have to be protected not just in the front, but
Everywhere.
all around. There's a pretty good dent there. You guys see that dent? Should we open it up and see if you survived? I don't see any dent at all.
I think you guys did all right.
You guys did awesome.
I would wear your spacesuit.
Way to go.
3, 2, 1.
Let's take a look. You've got great aim.
Right in
you
the
hit all of
face.
them right in the face. Take a look at that chunk there. It's a big impact right there.
I like the cloth on the inside. It makes it more comfortable for the astronaut.
Good. You guys made a comfortable suit if
I
nothing
like
else. Pretty good sized hole right there. But we learned something. You know, you guys are the first group that had cloth on the inside, and that makes the suit more comfortable. And with any of these tests, it may not be about it surviving this test, but what we learn from that to move on to our next test. So good job, guys.
Great job, you guys. And the name was? NASA DJ. Okay, here we go. 3, 2, 1.
Again, right in the nose. There's a nice little divot there. You guys see that? Guys, I don't see anything there. Way to go.
Great job.
You guys did a great job designing these suits. I'm really impressed, but here's the big key. How do you think they did?
I saw a lot of great designing and engineering work going on here today. I would wear any of your potato suits in the future, so I think you did a great job.
Thank you.
We're joined again by Dr. Kathleen Lewis, and she's going to talk to us a little bit about real spacesuits.
Hi, Marty. I'm back again, and I'm going to talk about what the spacesuit's functions are. And basically, the spacesuit has 4 functions. It protects the astronaut against the vacuum of space, and that's basically keeping the air inside. And it's pretty simple. It's a big rubber or plastic bag that keeps the air and oxygen inside and from going into the vacuum of space. The other objective, the next one, is protecting the astronaut against the lack of heat radiation in space. You're in there in a vacuum, it's like being in a thermos bottle, but also if you're up on board the International Space Station working outside, the temperature can vary between plus and minus 250 degrees Celsius. It's quite a radical thing. The third thing that the spacesuit does is protect the astronaut against the solar radiation. We often don't think about the fact that our atmosphere does a lot to protect us, and it filters about 80% of solar radiation. That's radiation and light radiation as well, and the spacesuit has to do that, carry that load. And the final thing I'm going to talk about in a little more detail is how the spacesuits protect against this orbital debris, micrometeoroids, things that are flying in space at the same velocity that the spacecraft or an astronaut is traveling at, 17,500 miles an hour, really going around fast. And if any of these tiny little things that NASA can't track, things that you can't dodge, and when large objects are approaching the space station, astronauts will go into the center to hide from them for safety. But these tiny little things are the most dangerous. And what they came up with was a really unique, and what I think is an elegant design. They figured out that they didn't have to build a lead spacesuit to protect the astronauts. That would be really unwieldy. Even though you don't have very much weight in microgravity, you still have to carry that weight around. So what they did was they sought lightweight textiles and they layered them in a way that a particle going through, even traveling at 17,500 miles an hour, would go through the first layer, break apart, and lose velocity, lose energy, and make itself into smaller pieces, go through the next layer, and losing energy, velocity through each subsequent layer until it comes at rest in one of these middle layers. And it's worked. We've never had a spacesuit fail from a particle penetrating that barrier layer that's keeping the air inside.
That's awesome. Would you mind answering a few questions?
I'd be delighted to.
All right, we're going to start with a video question, again from South Valley Middle School in Liberty, Missouri.
Hi, my name is Ruby, and my question is, why are spacesuits white?
Well, that's a very good question, Ruby. Spacesuits don't have to be white. They are white if they're going to be worn outside in space. You saw a picture earlier of astronaut Don Thomas, and he was wearing an orange spacesuit. That's known as a pumpkin suit. Those suits are only meant for launch and entry, and they're safety suits. They're what pilots call get-me-down suits. They are only really expected to be used if something happens to the spacecraft and the astronaut has to parachute down to Earth. If an astronaut's walking in space, he wants something white that's reflective, that's going to reflect that solar energy that I talked about before. So white for outside, any other color for up and down.
Awesome. We've got an audience question now. What's your question?
How many layers can be in the spacesuit?
That's a really good question, and it's varied over time. In the earliest EVA suits that astronauts wore in space, there weren't very many layers, but they were very quick missions. These were modified pilot suits that had about 5 or 6 layers. For the Apollo program, they designed a spacesuit that had 21 layers, and they had all sorts of synthetic fibers, the textiles that I talked about in those 21 layers. Today, in the spacesuits that astronauts wear to work outside the International Space Station, they have 14 layers. They're very similar to the Apollo layers, but they've managed to improve the textiles that they use. So where they had 2 or 3 layers, it's been combined into one single layer, but they work the same way.
Awesome. Great question. Yes. We're going to go to an online question now. What are the main materials needed for spacesuits?
There are a lot of materials, and that's a very good question, and I could almost give you a list. The outer side, the white layer, is what's known as super beta cloth. And it is a fiberglass fabric, and each of the fibers on that outer layer is coated in Teflon. It's coated in Teflon because they discovered early on that beta cloth, the fiberglass cloth, would break apart and wasn't easy to stitch and make into a spacesuit. On the inside, there are a lot of aluminized films and fibers that go in. There's Dacron, and in today's spacesuit, there's a mesh. On the very inner layer, there's a bladder, and that's the It's polyurethane now. It used to be rubber.
Awesome. Well, thank you so much for answering those questions. I'd like to thank you for joining us on the show today. I'd also like to thank our guests, Dr. Andrew Johnston and Dr. Roger Thompson. I'd like to thank my co-host, Beth Wilson, as well as our audience here from Friendship Charter School. Thank you guys for joining us today. And I'd like to thank all of our online viewers, both on the Smithsonian website and on NASA TV. And then last but not least, be sure to tune in next month on March 18th as we take to the skies in hot air balloons for the next episode of STEM in 30. Thanks for watching.